In this video, I'm going to demonstrate some equations and solving equations that require you to use logarithms. I am only going to do the odd problems in the video, and then when I post the answer key, I'll have the answers for the even worked out with their solutions so you can check those. If you do have any questions about the even problems, odd problems, any of the problems, send me a message, canvas me, let me know what's going on. When we look at these problems, and I'm going to zoom in on number one here, what I always look to do first is to see if I can avoid using logarithms. If I can rewrite the two bases as the same thing and just work with my exponent rules, I actually prefer to do that. Unfortunately, I know of absolutely no way to make 3 and 19 have a same base. So knowing that, what I can do is take the log of both sides. Now, the log that I'm using is the log base 10 that's on your calculator. So I'm going to have log 3 to the x is equal to log of 19. Now, one of my exponent rule properties for logarithms lets me take this exponent and fly it to the front as a coefficient. So this becomes x log 3 equals log 19. I'm going to divide both sides by log 3. And so what ends up going in my calculator then is this fraction. So I'm going to actually split screen right now with, I do have Calculate 84 here. All right. And I am literally using this log button. All right. So I'm going to create a fraction here that's log 19. Now I have this 19 in parentheses. So I need to get out of the parentheses. So I'm going to hit the little right arrow, divided by log 3. Now, if you have your own calculator, you may have a calculator that'll start the parentheses for the logarithm, but maybe not end it. So you need to make sure that you have those arguments, the 19 and the 3, completely enclosed in parentheses. So my calculator gives me this handy dandy answer, which is nice. I am not going to say paranoid, but if you guys have been watching my videos, you know Miss Kern tends to make mistakes, all right? So to avoid that or catch my mistakes, I almost always check my work. So I'm going to do a quick store. I'm going to make that into x, and then I'm going to quickly make the calculator do 3 to the x, and oh, look, I get the answer of 19. So I know I didn't screw this one up. So now I know that this is my answer. Let me do a quick pinch in, round to the nearest 10,000th. So 10,000th means 4 decimal places? Tenths, hundredths, thousands, tenths. Yeah, it's 4 decimal places. Okay. So 2.6801. All right. So that's problem number 1. I'm going to slide right on down to problem number 3, and I'm going to do the same thing. All right. There's no way I can make a base, a 10 and a 51.6 have the same base. So I'm not going to even bother trying, not going to take any time with that. What I am going to do is take the log of both sides. So log 10 to the n equals log 51.6. I'm going to fly that n in front. All right. And that's why we use this property, because it takes the exponent and basically makes it no longer an exponent, which is kind of nice. So we divide both sides by log 10. All right, so again, this fraction right here is what's going to go into my calculator. So log, now my calculator already started the parentheses, so 51.6. I need to get out of the parentheses, divided by log 10, enter. Now, not that I don't trust myself, but yeah, I'm just going to check it just to make sure. So store it in x because I'm lazy, and we're going to do 10 to the x. And I want, when I hit enter, to get 51 I want that answer, 51.6. So this means that n is equal to 1.7126. All right. Moving right along. All right. Now, problem number 5, the exponent has gotten a little bit more complicated, I guess is the right term for it. But 13 and 55, not going to get like bases out of those. So let's go ahead and take the log of both sides. So log of 13, p plus 5 is the exponent, equals log of 55. I'm going to fly this power in front, but I want to be careful because the whole thing needs to stay together with that log 13 as the multiplier. Now, you could distribute log 13 to both sides, not to both sides, to the parentheses p plus 5 and solve. Or, I'm going to be a little bit lazy here. I am going to divide both sides by log of 13. All right, so those are going to cancel. So now I've got p plus 5 is equal to log of 55 over log of 13. And then to get rid of the plus 5 that's attached to the variable p, I'm going to go ahead and subtract 5. So p is equal to log of 55 over log of 13 minus 5. Now, I've been working with the TIs for a long time, so I can put this whole thing in at once. If you think you're going to have problems with it, take it apart in pieces. Put in the log of 55, all right? And I'll actually show that. So log 55, hit enter. Now, just immediately hit divide, all right? So it'll take your, whoops, hold on a second. What the heck just happened? There we go. Sorry about that. So it'll take your last answer and just continue working with it. So now we're going to put in log of 13. So log 13, go ahead and hit enter again. And now I'm going to subtract 5. So you can absolutely take this apart in pieces if you think that's better for you with whatever you know how to use for your calculator. If you know how to do it all together, do it all together. What I do know I'm going to do is now store that in X, and I'm going to test it. Because, well, I'm going to. All right. If I can prove to myself that I'm getting the right answer, which this 55 matches that 55, I've just proven that this is the right answer. I like to do that. And it didn't take me very long. So negative 3.437, 6 and 5 would round up to 7. All right. Okay. Moving right along. Problem number 7 here. 15 to the 5v is equal to 87.8. I did a cursory, quick check. No, 15 and 87.8 are not going to turn into a like base, but I can take the log of both sides. So let's see, log of 15. Now, instead of putting that 5x in the power, you could immediately put it in front as your multiplier. Totally fine. All right, so you kind of understand that that's where we're going to with this process. Now, to get v completely by itself, I need to divide by both 5 and log of 15. So go ahead and do those at the same time. So 5 log of 15. So the 5 and the 5 will cancel. Log 15 and log 15 will eliminate each other. So v is left. And this nifty little fraction is going to go in my calculator. All right, so in the numerator, I have log 87.8. Now, the one thing you want to be careful about is that both of these pieces are supposed to be in the denominator. So when I hit divide, I'm actually going to put a set of parentheses to force my calculator to put both of these together in the denominator. So 5 log 15, and I'm going to close the parentheses I started. All right, hit enter. Now, again, I always do this. I'm going to check it. Okay, so store that in X. So 15 raised to the 5x is 87.8, which is exactly what I wanted it to be. So that means that v is equal to 0.3305. Okay. All right, so that's the first page. I'm going to keep going right into page number 2 here. See if these become any more complicated, any more difficult, figure out what's going on with these problems. Okay, log of both sides. So I'm going to have the log of 19. This whole power is going to come in front. So 1.6 minus 2k. I can fit that in there. I can. Okay. Equals log of 23. I'm going to divide both sides by log of 19. So log of 19. Okay, so that's gone. So I've got 1.6 minus 2k is equal to log of 23 over log of 19. Now, I want to be careful here to make sure I get all the pieces in the right places. So this 1.6 needs to go, and it's positive right now. So it's going to be negative 2k left. So log 23 over log 19 minus 1.6. And then to actually finish solving for k, I would need to divide both sides by -2. Now, that would require me to have a fraction with another fraction with a whole bunch of work. So, again, if you're good with your calculator and you know how to make it work, make it work. What I'm going to do is put this into my calculator, get the answer there. Then I'm going to take that answer and divide by -2. So log of 23 divided by log of 19 minus 1.6. Okay, so that's going to get me an answer. Now I'm going to take this answer and divide it by -2. Okay, and because I trust my calculator to tell me if I've done something horribly wrong, I'm going to test it. So 19 raised to the 1.6 minus 2. I used x. That's I tend to store it in x all the time. And that's equal to 23. So that tells me that this is my answer for k. All right, so, and if you want to show the division by -2 here, right, divided by -2, k is equal to 0.26755. We round to 6. Excuse me, I had to cough there. All right, so we've got number 9 done. Let's roll on down to number 11 here. And number 11 is pretty much the same idea. So let's go ahead and roll right into it. So we've got 2k minus 10 flies out front as the coefficient to log of 17. So that's going to equal log of 95. I'm going to divide both sides by log of 17. So those go. Let's see. So 2k minus 10 is equal to log of 95 over log of 17. I'm going to add 10 to both sides. So log of 95 over log of 17. I'm going to add 10 and then divide both sides by 2. Now, if you absolutely can put this into your calculator in one shot, do it if you want to. All right. So log of 95 divided by log of 17 plus 10, and then all of that divided by 2. Probably should have a parentheses here to close that up. And I believe my answer is 5.8 something, but I trust myself not, especially with the calculator when I tried to put all of that in it. Whoa, what just happened? Okay, still have the x value. Good. All right, so 17 to the 2k minus 10 is equal to, hey, it equals 95. So 5.8037 if I round it right. All right, I believe there's more. All right, now problem number 13. One of the things at 13 and 15, you can see both of them right now. You may notice there are variables, variables and exponents on both sides. So we want to deal with that. And we're going to do the same thing we've been doing. We're going to take the log of both sides. So when I take the log of the left side, this exponent can fly in front. So x plus 6 log 4. When I take the log of the right side, that x exponent can fly in front as a coefficient to log 6. Now, the problem is we've got variables on both sides, and I'm not a huge fan of that. So what I want to do is be able to collect all my x's on one side. In order to do that, though, I need to distribute this left side. So we're going to have x log 4 plus 6 log 4 equals x log 6. So I see that I have an x here and I have an x here. So I'm going to take this x term, this x log 4, and subtract it to the other side. So that puts the constant, 6 log 4 is a constant, there's no variable, alone on the left. So x log 6 minus x log 4. Okay. Now, things I notice. I notice that both of these terms on the right have the variable x. So what I can do is actually factor that x out, okay? So if I factor that x out, I would have log 6 minus log 4 left over. Remember, factoring is like reverse distributive. And now, because I have x, a single x, I can divide both sides by log 6 minus log 4. And that should, provided I didn't goof it up, get me the right answer. So this needs to go in the calculator. Now, I want to keep both parts of my numerator together, and I definitely want to keep this whole denominator together. So to do that, I'm going to start a set of parentheses. So 6 log 4, end the logarithm parentheses, and then end the parentheses for the numerator. So that's all grouped together. Divided by, now I'm going to group the denominator pieces together. So log 6 minus log 4, and then end it. Now make sure that the 6 and the 4 are completely closed off. So you started after the logarithm, ended after the 6. After the log here, you got the 4 completely enclosed in parentheses. All right, let's go ahead and hit enter. And now I'm going to still store it, and I want to test it. Now you can either test it together if you know the test functions on your calculator, or if you don't know those, you can do what we've been doing. So I'm going to do 4 raised to the x plus 6 power. I'm going to hit enter. And then I'm going to do the exact same thing with 6 raised to the x. And these two answers, as wacky as they are identical, which tells me that this answer is the correct answer for x. So x is equal to 20.5141. So it's a little time consuming when you have variables in the exponents on both sides, but if you follow the same process that we've been doing, you're just adding this little, and I'm saying little, but this little extra factoring step where you get all the x's to one side, factor out the x, and then solve for the x. All right, I'm going to go ahead and slide on down to number 15 here, which I'm pretty sure, yep, that's the last problem that I'm going to be going through, and I will put the key up with the other half. So let's run through this one. I'm going to take this exponent, fly it in front. So 9 plus x log 6. I'm going to take this exponent, fly it in front. So x minus 2 log 3. All right, we need to distribute on both sides. So 9 log 6 plus x log 6 is equal to x log 3 minus 2 log 3. All right, I want all my x's on one side. I want all my constants on the other. It is not going to matter in the slightest which side you move to. So I'm going to go ahead and take this 2 log 3, add it to the left side. And I'm going to take this x log 6 and subtract it. So 9 log 6 plus 2 log 3. So everything on the left side now is just numbers. It's just constant values. And then on the right side, x log 3 minus x log 6. So little x here, little x here. I'm going to factor those out. Okay. So this whole left side, as messy as it is going to stay what it is. All right, x log 3 minus log 6 when we factor out the x. Divide both sides by log 3 minus log 6. So log 3 minus log 6, those are gone. X is equal to, all right. Yeah, this whole mess has to go in, all right? So take your time. Okay, especially if you're not used to working with the calculators, but take your time with it and get that whole thing in the calculator. So start a set of parentheses. I'm going to just put in the numerator. So 9 log 6 and that logarithm plus 2 log 3 and that logarithm. Close, hold on one second. I think I did the wrong thing. Oops, I have an extra parentheses here that I'm trying to get rid of. There we go. All right, so log 3, close that parentheses, close that one. Okay, there we go. Finally got the whole numerator in there. Divided by, see, told you to take your time. Need to take my own advice. All right, log 3, let's close that one up, minus log 6. Close that one up and the parentheses. Wow, that is one wacky answer. Let's see if it's the right wacky answer. So I'm going to go ahead and store it as x. Let's see, 6 to the 9 plus x is equal to that mess. 3 to the x minus 2 is equal to, well, look at that. It's the same mess. Now, it doesn't matter what these answers actually are. What matters is that number by number by number, they match. So that tells me that this is, in fact, the correct x value. So x is equal to negative 26.434. That 5 will turn into a 6 when I round it. All right. So guys and ladies, I know these problems can be a little bit of work. If there are any steps that you are confused on, drop me a message. Let me know how I can help. The answer key will be popped up with everything filled in, so don't feel like you have to worry about any of those even problems. If you do have any requests for seeing anything about the even problems, let me know and I can make